Okay, guys, example number 2 here says data distributions. A stem and leaf plot shows how data are distributed. From a stem and leaf plot, you can draw conclusions about the data. For example, you can see if data values are grouped together or tell whether most of the data are above or below the mean. Okay? Now, example number 2 says the stem and leaf plot shows the prices in dollars of pairs of sneakers at 2 shoe stores. What can you conclude about the prices at the 2 stores? Okay, so I'm looking at this stuff. I've got store A, and here are the prices for store A. I'll just kind of box it in. How's that? And then here are the prices for store B. Guys, this stuff down here at the bottom, this is called a key. That means that 30 stands for $30 in this one. So, of course, 45 would stand for $45. All right. Well, looking at that, what can we tell? Any ideas? Evan, what do you got?
Store B is cheaper.
You think store B is cheaper?
Yes.
All right. So store B is cheaper. Some may say have a better value, whatever. And how did you know that, though, Edward? Just looking at it.
Because most of them are 4s, and the other one there's 6s and 5s.
Right, right. Edward says that most of the prices for shoes at store B are in the $30 to $40 range. Whereas if you look at store A, their shoes are more spread out, from 30s all the way up to 65. Okay, so it looks like they have a wider variety in prices of shoes, and store B has a greater number of shoes that are of lesser price or cheaper value. Yeah, Reed, what do you think?
Store B has the most expensive shoe.
Store B does have the most expensive shoe with $69, more expensive than store A's $65. Yeah. Okay. Good point. Anything else anybody see? Is that it? I mean, that can be it. We're just kind of looking at this information, and it gives us an idea. We don't know where these stores are, what these stores do or anything, but it gives us an idea of what kind of store they are. You know? What do you think, CC? They both have 19 pairs of shoes, at least in the numbers that they checked here. Yeah. CB. Now, CB says he thinks that store A is cheaper. And why is that, CB?
Well, they may have less. They may have it more spread out.
Their prices are more spread out, but
The 4s and the 40s and 30s, they can still stack up to equal a lot of money.
there's still a lot of options in 30s and 40s here for store A. Yeah. So think about this. Here's a way, and guys, I want to go just away from interpreting it right now, but looking at the numbers, it's an easy way to find a median. Remember, a median is the middle number. Median equals middle number. Now, what that means is we need an odd number of items to have a middle number, right? So, for instance, if we take 11, if we have 11 items, that means we have 5 above and 5 below with 1 in the middle. Now, it's good because these have 19 each, which means that we have 9 above, 9 below, and 1 in the middle. Okay? So if I count off 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, this is the 10th number, and then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 above. So I know that the median for store A is $49. Okay? Now the median for store B, it's also 19, so I've got 9 below, and then the 10th will be the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is $43. Okay? That means at store B, there are as many below 43 as there are above it. At store A, there are as many below $49 as there are above it. Okay? All right. So that's how we can organize that stuff and sort of analyze it, give us an idea about that information. All right. Good job, guys.